everyone, welcome back to Atomic Ascent, the place where chemistry becomes simple, logical, and truly fun to learn. If you are a student preparing for competitive exams like JEE, NEET, or other entrance tests, or you simply want to build a strong command over chemistry concepts, then you have just landed in the right classroom. So, today we are going to start Chapter 2 Structure of Atom from class 11. So without ado, let's get started. This chapter mainly focuses on the structure of atom, what is an atom and what does that atom is consisted of, right? Before jumping into the structure of atom, we should know a few things that late in 400 BCs also those Greeks, they knew about, they had a knowledge of atoms. Okay, even the Indian rishis, okay, they had a knowledge about these atoms, which they called it Parmanu. Okay, so they said that there are certain structures or substances that can never be broken down into smaller parts. So we, our Indian sages also knew about the atoms. Parmanu is what? It is an atom. Okay, so they knew, these old people, they knew about atoms, but they couldn't explain or experimentally determine that what is an atom. Okay, all right, so let's talk about the word atom. The atom word has been taken from word atomio. Okay, the meaning of atomio is uncut or uncuttable or indivisible. Okay, so this is a fundamental particle which is not divisible into smaller parts. The word atomio is taken from Greek language. Okay, so it means uncuttable or indivisible. All right, the next one is that first atomic theory which we got to know about. Okay, very first atomic theory, okay, which was a definite atomic theory. It was actually proposed by John Dalton. He was an English physicist and mathematician who talked about atoms, and we have studied about it in first chapter. Let's review it for some time. John Dalton said that atoms are the smallest fundamental particles. They are the smallest. What are atoms? Atoms are smallest. Okay, they are indivisible. They cannot be divided further, or indestructible, you can say indestructible. Okay, they cannot be destroyed, okay, into smaller part. These are the smallest particles. These particles actually take part in chemical reaction. They take part in chemical reactions. They are individual particles which actually take part in the chemical reactions. Okay, and for the same element, okay, for the same element, atoms are same. Okay, and for different elements, atoms are different and their properties are different. Okay, obviously when same element or different elements, the atoms of these same or different elements, they combine, they always combine in fixed ratio by mass. Fixed ratio by mass, or which actually propose the law of definite proportion. You might have remembered the law of definite proportion, in which we say that different atoms of different elements, whenever the compound is formed, they are always present in fixed ratio by mass. Okay, and uh, these atoms, they can never be uh, made up or destroyed in a chemical reaction. So obviously they follow law of conservation of mass. Okay, so these were few postulates of Dalton's atomic theory, which actually first told us about that what is an atom. But you know what happened? He said that it is the smallest particle, which is indivisible and indestructible, and up to his best knowledge, it was correct. But when later on new discoveries were there, we got to know that atom is not that much simple. Atom can be divided. Atom is divisible actually. Okay, atom is divisible means it has smaller atomic particles which are called subatomic particles. Okay, it is made up of these subatomic particles, and main three subatomic particles which we lot of time we come across those. These are electrons, protons, and neutrons. But we got to know them about them from different reactions. We cannot say that we have done it in theoretical way. These are proved by reactions or experiments. Okay, so these subatomic particles are the three major subatomic particles. Other than them, there are other subatomic particles also. Other subatomic particles are also there, and we were talking about them. There are alpha particles, that is positively two positively charged helium atoms. Beta particles are there, beta negative particles, which are electron emissions are called. And then there is beta positive particles or positrons are there. Okay, there are quarks, there are neutrinos, there are positrons. Okay, there are lot of other particles are there, neutrinos. Fine, so there are lot of different subatomic particles, but we are always concerned with these three when we are talking about JE or normal exams or in class 11 or 12th. So let's talk about their discovery, how they were discovered, and how these subatomic particles came into existence, how we got to know about them. In today's video, we are only going to do about electrons, their discovery, who were their discoverer, and how it was discovered, how that particular what are the properties of electrons, which we are going to talk about in this video. So let's start with discovery of electrons, which is our main topic of the day. Discovery of electrons. This is the first subatomic particle which has been discovered. So discovery of electron was done in way back in 1800s, or you can say that 19th century. At the end of 19th century, what happened that there was a scientist named J.J. Thomson. Okay, he was actually working on certain experiment, and J.J. Thomson, what did he do? He actually took a glass tube, closed glass tube, and he added inert gases at very low pressure into these glass tubes. He also took two spherical plates and put them on the either side of the glass tube, and then connected them to outer source of battery. Okay, and he closed it, keep it at low pressure. He took various noble gases, obviously. Oh, it is very important to remember that they have taken noble gases, because if he had taken the reactive gases, the structure would have blast, because it is a glass tube. Okay, so he passed the electricity and he observed a few things. So this was an experiment. As you can see, there are two circular plates, and what is happening that this particular plate is actually emitting few radiations. Okay, these are called cathode rays, because this is a negatively charged electrode. And what happened, these charged particles are actually getting emitted from negatively charged electrode, which is known as cathode, and they get attracted towards positively charged electrode known as anode. And there is a small hole over here, and from there these electrodes actually these charged particle actually transfer and then pass to the other end of this tube. Now if we look at this animation, this can be taken in any side, and you can go any side and you can look at that what is actually happening over here, right? But how do we know that they have a certain charge? Because I'm saying it is a charged particle. So what we are going to do, we are going to apply electric field over here. Now when I have applied electric field, as you can see over here, these particles are getting attracted towards a positively charged plate of the electric field, right? If they are attracting towards positively charged plate, that means they have the opposite charge on them. So what is the opposite to positive charge? It is negative charge. So they get attracted towards positively charged plate because they have what they have negative charge on them. If we switch the plates once again, as you can see, it is also once again attracting towards the positively charged plate. Fine. What happens when you apply, okay, you can take it like this also. See, it is attracting towards positively charged. What happens when we apply a particular magnetic field? Now when magnetic field is applied, right, you can see that they are little bit attracted towards south pole. Okay, this is south pole. Okay, and when the poles are interchanged, once again it is attracting towards south pole. Fine. So what is happening over here, because south pole has positive properties in them, so it is getting attracted towards the oppositely charged pole. Fine. So this is what he actually did in the experiment. So what happened over here, this is a suppose this is a negatively charged, this is cathode electrode, and this one is anode, it has positive charge on it. So rays from the cathode are attracting towards anode. Because they are attracting towards positive charge, these rays, they must have negative charge on them. Okay, these are called cathode rays because they are originating from cathode. So this was the cathode ray experiment which J.J. Thomson actually performed. He did one more thing. He actually took once again the same glass tube he took. Okay, and as you saw in the experiment, what he did is he took a circular plate and made it perforated. Perforated means it had few holes in it, whereas the other plate was without holes. The plate without holes, okay, it was cathode, negatively charged, and plate with holes was anode, which was positively charged. Once again, a noble gas was added, or an inert gas was added at low pressure, and what he did is he once again switched on, and there were formation of these rays from cathode towards anode, and these rays, they passed through a few rays, okay, they passed through these holes. And what he had done already, that he has plated, okay, or painted the end on this perforated electrode with phosphorescent material or fluorescent material like zinc sulfide. Okay, now what is the effect of why he has used this zinc sulfide? Whenever these rays, they cross through these holes and strike with zinc sulfide, it actually glowed. Okay, even if the cathode rays were invisible, even if they were invisible, suppose, so he got to know that most certainly these rays are actually striking with zinc sulfide coating. Okay, he did the coating, and whenever these rays, they struck with the zinc sulfide coating, it actually glowed. He got to know few things about it then, that these so-called cathode rays, okay, had few properties. Cathode rays, these are rays which are made up of particles, and these particles have negative charge on them. Okay, and if they are particles, that means they are matter, obviously it has mass. That's why whenever it was striking with the zinc sulfide coating, it was glowing. So this is how he did this experiment, and he got to know that these rays were made. Okay, this was a discovery of electron by J.J. Thomson. A few things he also got to know about cathode rays, that cathode rays actually cause heating effect. Okay, so whenever they were performing this cathode ray experiment, what happened, when these cathode rays were made to strike a thin metallic foil, that metallic foil gets heat up, so they caused heating effect. Okay, one more thing you have to remember, the nature of cathode rays does not depend upon nature of cathode rays. Okay, it does not depend upon nature of any inert gas which was taken, inert gas which was taken in the cathode ray tube, and nature of electrode. Okay, whatever electrode you take, it does not have any impact on nature of the cathode rays, that how these cathode rays are forming, whether they are different or not, it does not depends upon the nature of inert gas or nature of electrode. So these were the few properties we got to know about it. Later on, these particles, which consist of cathode rays particles in cathode rays, these particles are called electrons. Okay, they are called electrons. Okay, so this was the major experiment. One more thing you have to remember, that when this cathode ray experiment he performed it, he also got to know about charge to mass ratio. Okay, charge to mass ratio. He got to know about this ratio of these particular elements or subatomic particles of electrons. Okay, what was it? Okay, this charge to mass ratio was E upon m ratio. It was for electrons, and he got to know that it is 1.7 into 10 to the power 11 coulomb per kilogram. So this ratio was actually discovered by J.J. Thomson in 1897. I have told you already, he did it in the 19th century. This charge to mass ratio was for electrons. Okay, now in the later on periods, what happened, that there was a scientist known as R.A. Millikan. Okay, he actually discovered that what is the charge on electron. He got to know about charge on electron by his experiment. The experiment is also known as oil drop method or oil droplet method. This was his experiment or oil droplet experiment. So let's talk about R.A. Millikan's oil droplet method, that how did he discover the charge on an electron. So this is the general structure of R.A.'s oil droplet method. What he did, he took a container, okay, and it was a metal container, so you should remember. And what he did was he took an atomizer. Atomizers are what, basically like you nowadays use perfume bottles or deodorant bottles. The spray which makes that watery material or oily material into very small drops, okay, or very fine mist, is known as atomizer. Okay, so it is same, it works as same. So there was oil in the atomizer, this is oil. Okay, and he took that oil, and through atomizer he made very small oil droplets. All right, and what he did was, it was a cylindrical container, obviously, so it had two charged metal plates. One was positively charged metal plate, which was on the top, and on the bottom, approximately in the near bottom of this container, there was a negatively charged plate. Now in this positively charged plate, it had very small hole in the center. Okay, and what he did, he let these oil droplets go through this small hole. Only one single droplet he got let it go, and let it go under the action of gravity towards a negatively charged plate. Now when there was one single oil droplet over there, what he did, he actually took an X-ray source, okay, and he irradiated this space between these two metal plates, okay, with X-ray. Now what happened, because of that, a few electrons are released, okay, and these electrons are attracted towards oil droplet, and they get attached to oil droplet. Now when these oil droplets they get the electron, they are negatively charged, Okay, now what he did, he maintained the charge of these metal plate in such a way that these oil droplets will suspend in between, okay, in the center of these two metal plates, so that he could observe it through the microscope. When he did so, the droplet becomes stationary and he observed it through microscope. Now the charge on the oil droplet, okay, and the charge on these metal plates, okay, and mass of the oil droplet, we are talking about few things. That charge, he maintained the charge on metal plates, right? These are electric metal plates. So the charge on these metal plates and mass of this single oil droplet, okay, it was obviously measured. He got to know about it, he knew about it, and through these two informations, what he did, he actually calculated the charge on electron, charge on one electron. Okay, so he did a mathematical calculations through which he got to know that what is the charge on electron. Now you might be thinking that how he got to know about the mass of the single oil droplet, right? When in the earlier stage, when there was no charge on the metal plates, there was only single drop which was, let to fall freely under the action of gravity. Then he calculated the mass of single oil droplet. Obviously that force is equal to mass, m into g is the gravitational force. He got to know about the mass. So when he calculated the charge of an electrode, so it comes out to be charge was 1.6 into 10 to the power negative 19 coulomb. Okay, he calculated it, R.A. Millikan, and Thomson has already done an experiment showing that what is the charge to mass ratio. That was 1.76 into 10 raised to power 11 coulomb per kilogram. Okay, so he needed to calculate mass. Mass comes out to be equal to charge on the electron divided by charge to mass ratio. Okay, so that was 1.6 into 10 raised to power 19 coulomb divided by 1.76 into 10 raised to power 11 coulomb per kilogram. Now coulomb was cancelled, kilogram went up. Obviously 10 raised to power 11 was also taken in the numerator, and when we calculated it, it comes out to be 9.1 into 10 raised to power negative 31 kilogram. So this was the mass of an electron. Okay, so this is how the mass of an electron was calculated. Okay, so in the later on periods, he got to know that this mass of electron is very small than the mass of hydrogen atom, a single hydrogen atom. And when he calculated it, when he got the relationship between it, the mass of an electron is 1 divided by 1.837 part of mass of hydrogen, single hydrogen atom. Now he also generalized from it. We can say that mass of electron is very small, extremely small. Okay, and due to which it can be neglected or it is negligible. So whenever we are talking about the mass of an atom, electron's mass does not has any effect on it. So whatever the mass of electron will be there, it does not have any effect on the mass of an atom. It is present or not present, it is only to maintain the electrical neutrality of an atom, but it does not contribute towards the mass of an atom. Okay, from here the electron was actually defined, that what is the definition of an electron. So what is the definition of an electron? So electron is a subatomic particle. Okay, electron is a subatomic particle that has unit negative charge. Okay, its charge, which is 1.6 into 10 raised to power negative 19 coulomb. It is unit negative charge and has very small, has extremely small mass, which is 9.1 into 10 raised to power minus 31 kilogram, and has mass of 1 divided by 1/837 times of 1 hydrogen, or you can say times of mass of 1 hydrogen atom. Okay, so this is the scientific definition of an electron. So an electron is that it is a subatomic particle that has unit negative charge. Okay, you should remember that what is that unit negative charge. Okay, and it has extremely small mass, which is 9.1, which is negligible mass also. Okay, 9.1 into 10 raised to power negative 31 kilogram, and has a mass of 1 divided by 1/837 or 1837th times of the mass of 1 hydrogen atom. So this was all about electron and its discovery. And that brings us to the end of today's sessions. I hope you have understood that how the electron was discovered, what were its properties, and what is its definition. Okay, what is its mass, what is its charge, and what is the relationship of its mass with the mass of hydrogen atom. And you hopefully will be able to solve questions based on this particular topic. Always remember, chemistry becomes easy when you focus on concept first and then practice consistently. And that's exactly what we will be doing here on Atomic Ascent. So thank you so much for watching. Keep learning, keep practicing, and as always, keep ascending. See you in the next video.